In the previous video, we discussed the periodic table and how it is improved by chemists to become a better catalogue of elements as we know today. They were collected and listed in order of increasing atomic number. The elements were put into vertical order called groups with other elements that reacted similarly to them. The periods of the periodic table tell us the number of shells or orbitals an atom is made up of. For example, sulfur is found in period 3, which means the sulfur electron configuration consists of 3 shells. Calcium is in period 4, so the atoms will have 4 orbitals. The periods start with the number 1 and go all the way up to 7, meaning the biggest atoms will have 7 shells. Knowing this is super helpful when drawing atoms because it tells you how many circles you need to draw. You can look at the atomic number to tell you how many electrons you have to spread out between those shells. There are a few patterns known as trends of the periodic table that we need to know about. The first trend is atomic radius, which also determines atomic size. An effective atomic radius is the distance from an atom's nucleus to its outermost orbital, about which 95% of the electron density is found. This can be measured as half of the internuclear distance, and it decreases across a period. So, as you go from left to right across a period, the atoms get smaller. This is because electrons are being added to the same shell. Why does this matter? Well, the outer shell electrons are being pulled inwards by the positive protons in the atom's nucleus. So, the more electrons on the outer shell, the stronger the attraction, which means the more inwards the atom will be pulled in, so the smaller it will be. This attraction pulling the electrons inwards is called the electromagnetic attraction. The next trend is ionic radius, which is the radius as atoms form ionic bonds. It generally decreases as you go across a period from left to right. This is because there are more protons in the atoms, but with the same number of shells, and so the electrons on the outer shells are subjected to electromagnetic pull, pulling them inwards. While forming bonds, cations are smaller than its parent atoms as electrons are removed from the outer shell. Anions are therefore larger than the parent atoms as electrons are added to the shell, resulting in increased repulsions between electrons and a decreased electromagnetic attraction due to the protons being outnumbered by electrons. This makes the trend a bit complex. Knowing about the atomic radius and ionic radius is very important. It not only gives the information about electron distribution, but also helps us explain the behavior of atoms of an element such as energy and reactivity. However, being informed about trends in radius is not enough to understand the periodic table thoroughly. So, in the next video, we will dig deeper into other trends in periods, ionization energy, affinity, and lastly, electronegativity. In the previous video, we discussed the 2 trends in periods, atomic radius and ionic radius, which related to the size of an atom. Now, let's move on to the next trend, the ionization energy. Ionization energy is the energy needed to remove an electron from an atom. This is because there are gradually more protons in the atoms, which means a greater electromagnetic force on the outer shell electrons. And this increases as you go across a period from left to right. Therefore, more energy is needed to remove electrons. The next trend is electron affinity. This is the energy change related to the ability of an atom to gain electrons towards itself. Electron affinity increases from left to right across a period as atoms get smaller, so they are more able to pull electrons towards themselves. To achieve stability, the desired configuration of an atom has 0 or 8 electrons on its outer shell. Generally, the metals of group 1 and 2, hence they have 1 and 2 electrons on the outer shell, do not want to gain more electrons and would rather lose them when they react to more easily achieve a stable 0 electron configuration. Fluorine from group 7 has a super high electron affinity because of its small size and because it has 7 electrons on the outer shell, which means it only needs to gain 1 more electron in order to have a desirable full outer shell and be stable. Electron affinity rules do not apply to noble gases because they don't try to gain electrons as they already have full outer shells. This is what makes them so stable. The final trend is electronegativity. Electronegativity is the ability of an atom in a molecule to hold on to the bonding electrons. The electronegativity increases as you go across a period from left to right, inversely related to atomic radius and size. This is because the smaller atoms means the nucleus is closer to the bonding electrons of the molecule. We've taken a look at the periodic table as we currently know it to look like. However, the periodic table is always periodically being revised. In fact, the most recent revision was published in December 2018 concerning the atomic weight interval of element argon. Usually, the elements in the periodic table are named after famous scientists or the place they were discovered. However, the only country actually named after an element in the periodic table is Argentina, named after the element of silver, Ag, which in Latin is pronounced argentum. Wouldn't Messi be impressed? Thank you for your continuous support, especially our valued patrons and members who have been encouraging us to keep producing more quality content.